Hello everyone, my name is Nikitan Dobaria and here we are discussing basic electrical engineering in which we are discussing first chapter DC circuits. In this video lecture, we are going to discuss various energy sources over here. Let's start the various electrical energy sources in which first of all we will start with independent voltage source and current sources. So these are the symbols of independent voltage sources. First of all, what is independent source? Independent source means value of that source or output of that source doesn't depend on any other factors. As an example, here as we are discussing the independent voltage source, these are the symbols of independent voltage source. Here, first symbol that is representing a DC voltage source, and this second symbol that is representing the alternating or AC voltage source. Now, what is independent over here? Value of this DC or AC source is going to be constant whether if you are connecting this source with any circuit. So basically, if you connect this voltage source with a resistor, let's suppose with a resistor. Now, if you are changing the circuit parameter, so in any condition, output voltage of these sources is going to be constant, and that's why they are known as a voltage source. So there are two terms: independent and voltage source. Independent means value of that voltage don't depend on any external parameter or any circuit parameter. Second, why it is voltage source? Because it is providing constant voltage. That's why that is known as a voltage source. Now let's consider another source which is given over here in this diagram, where this first current source which is representing a DC current source and a second current source which is representing a alternating current source. Again, both are independent current source. So again, what is independent here? The value of this output current doesn't depend on any circuit parameter where it is connected or any other external parameter. Output current of these current source is going to be constant always. And why it is current source? Because it is providing a particular value of current. So if you are connecting these current source with any circuit, and if you change any parameter, as an example, if you are connecting this current source with resistive circuit, and if you are changing the value of resistance of that circuit, still value of current of this source will not change. So that are providing the constant current, and that's why these are known as the current source. So basically, we had cleared two terms over here. First, independent. Independent means output parameter of that particular source don't depend on any circuit or any external parameters. Output parameter of those sources is going to be dependent on itself, and that is going to be constant basically. Second is voltage source and current source. Voltage source means which is providing output or output energy with a constant voltage. The same way, current source means a source which is providing output at constant current. So these are the example or symbol of voltage source, and these are the symbol of current source. Now let's move toward the next topic, and that is dependent voltage source and current sources. First of all, dependent source is represented by diamond shaped symbol, and there are four possible dependent sources. First one will be voltage dependent voltage source. So let's discuss the first one, voltage dependent voltage source. So this is the symbol of voltage dependent voltage source. Means this is a symbol of voltage dependent voltage source, where here we are getting the output voltage. So this is the symbol of this source. As mentioned, this is in diamond shape. Now this is the some another part of circuit where we are having a resistor, and voltage across this resistor is V1. Now there are some certain condition, and because of that condition we said that output voltage of these source is having value is equal to 60 into V1. That means if we are changing the value of V1 over here, if V1 will increase, then value of the source will increase. If V1 will decrease, then value of source is again decrease. That means the output voltage of this source is depending on this voltage. That's why that is dependent on voltage. That's why voltage dependent. And which type of source is this? Voltage source. That's why voltage dependent voltage source. Similarly, if we discuss the next source, and that is current dependent voltage source. Again, this is voltage source. That's why this is the symbol of voltage source in diamond shape. Again, having plus or minus value. Plus or minus value is representing the voltage source. But now value of this voltage source is depending on current. And for that, this is the another circuit part over here. And through this resistor, current I1 is flowing. And here value of this voltage source is K into I1. That means if we increase the I1 current over here, value of voltage over here will increase. If we decrease the value of I1 current over here, then voltage across this or voltage of this voltage source will decrease. Basically, output voltage of the source is depending on this current. That's why this is known as a current dependent voltage source. And next is voltage dependent current source. Now, first of all, let's observe the difference between symbol of voltage source and current source in condition where it is dependent. Again, diamond shape will be same as it is, but now when we represent current source, dependent current source, basically in this diamond shape we are showing the arrow which is representing the direction of current. So this is the dependent current source. This is symbol of dependent current source. And now value of this source is given by 0.2 V1. And what is V1? V1 is voltage across this resistor. That means if V1 will increase, the value of current through this source is increase. If V1 will decrease, then value of this current will decrease. So that means this is dependent on current. Sorry, this is dependent on voltage. That's why voltage dependent current source. And last source, that is current dependent current source. Here, this is the another symbol of current source which is having value beta into I1, and I1 is mentioned over here. That means if we are changing the value of this I1 here, beta into I1, well, so this is changing the value of this current source, and so this is dependent on current. That's why current dependent current source. So this was the fourth dependent source. Now, up to now we have discussed the various sources in which mainly we have discussed voltage source and current source. In this series, next we will discuss the source conversion. That means if a voltage source is given and which is having a series resistor, means a resistor in series with that, so that can be converted into its equivalent current source. And when we find out the current source, then symbol of that current source is going to be current source and a resistor in parallel connection. Same way, if current source will be given, we will convert it into a voltage source. But let's find out how we can convert the voltage source into current source or current source into voltage source. But before that, let me clear one thing over here. When we will transform the voltage source into current source or current source into voltage source, first of all, we will always consider a practical source. Now, what is practical source? We can divide sources in again two categories: ideal and practical. Ideal source means where we are not considering any losses, any internal resistance, and practical sources where we are considering its losses, its internal resistance. So here also we are considering practical source. And when we consider practical source, always remember that if we consider practical voltage source, its internal resistance will be shown in series with that voltage source. And in case of current source, that internal resistance of that current source will be shown in parallel connection with that current source as shown in this given diagram. And here we are going to convert this voltage source into current source by considering that these are the practical sources. Now, if we want to convert sources in each other, there should be some conditions which should be fulfilled. First one, open circuit voltage, and second one, short circuit current. In this both circuits should be matched. That means if we consider this circuit as an open circuit, and again if you consider this open circuit, the voltage in both circuit, open circuit voltage should be same way. If we short circuit this branch AB, and again if we short circuit this branch AB, so this short circuit in both cases must be same. If this two condition will be fulfilled, then and then only this two can be considered as an equivalent, and that in that condition we can convert into each other. And let's suppose that if this condition will be fulfilled, then what final condition will be derived? At that final condition, we can derive that. Let's suppose that if you want to convert this voltage source into its equivalent current source, so what will be the value of current source which is over here? That can be derived by this given equation, where I is equal to V by R, where V is given over here, R is given over here. And a resistor which is in series connection over here, that is going to be in parallel connection over here. Both are having the same resistance here in series and parallel. So basically, this is the method how we can convert voltage source into current source. And same way, we can convert current source into voltage source also. Now, before that, let's consider one example over here where we have a 10 volt source and having 5 ohm resistor as a series connection, and we want to convert this voltage source into current source. So as mentioned in our previous slide, if you want to find out the value of this current, that can be derived by this I is equal to V by R equation. So V by R is 10 by 5, so that will provide the 2 ampere over here. So that is going to be 2 ampere, and resistance which is going to be in parallel having the same value as it is in series connection over here. So now current source having 2 ampere value and 5 ohm resistance in parallel connection. So this is its equivalent current source. So this was the conversion of voltage source into current source. Now if you want to convert it in reverse way, so for that we had considered a current source over here which is having value Is and a resistor in parallel over here. Now if you want to convert this into voltage, so as we had relation I is equal to V by R, by that equation you can derive the V is equal to IR. So basically here we can derive the value of voltage by this I into R. Is into this R, we are getting the voltage over here, and this same resistor is going to be in series connection over here. So this is the current source to voltage source conversion. Now next, we will discuss the various network simplification techniques over here. As an example, if we are having two voltage source in series connection, as an example here, V1 and V2 are in series connection, and both are having same direction, the positive to negative, positive to negative. So in this case, we can convert these voltage sources into a single voltage source by this equation V1 plus V2, as both are having same direction. We can add them both. And again, both are in series connection, but in the reverse direction. V1 is in this direction and V2 is in this direction. So basically, both are in opposite direction with compared to each other. So in that case, we can find out the resultant voltage by finding its difference. And whatever V1 or V2 having the larger value with compared to another one, we are getting resultant according to it. As an example, if V1 is greater than V2, we will find out the V1 minus V2, and the resultant voltage will be in the direction of V1, which is having large value. And same way, let's discuss another technique for current source. If both current sources are in parallel connection and again having same direction, we can convert it into a single current source having a value I1 plus I2 if both are in same direction. But let's say if both are having opposite direction when compared to each other, in that case we will find out the difference of these two. But we will also consider a condition if I1 greater than I2 or I1 less than I2. Let's consider it. If I1 is greater than I2, so we will find out the resultant as I1 minus I2 in the direction of I1, which is large value in that case. Now let's say two voltage sources are in parallel connection. So what will happen if both are having same value? That means equivalent source will have same value. V1 is equal to V2 means both can be mentioned over here. But if V1 is greater than V2 or V1 is less than V2, in that condition, what will happen? This resultant source will have value of a voltage source which is having a large value. As an example, if we will have a V1 greater than V2, here, if we will have a V1 greater than V2, so here we will put the V1. Similar way, if we consider two current sources in series connection, and if both are having same value, then we can replace it by a single source having a value I1 or I2 maybe. But again, if both are having not same value, as an example, assume I1 is greater than I2. So here value of this current source is going to be I1. So these were the various network simplification techniques based on voltage source and current sources. Thank you for watching this video.